Nos, nagyon sok szeretettel üdvözlünk benneteket a sokadik állomásán a nyári tábor sorozatunknak. A mai napon annyi kicsi változás lesz, hogy Máté kollégám Csehországból ma nem tud csatlakozni, úgyhogy Adrián Lázár kollégánk fog Romániából előadni nektek. Ő is ugyanolyan hálózati specialista, mint Máté kollégánk, és megmondom őszintén, most fejből nem tudom, hogy épp melyik hálózatos előadás fog következni, de remélem, hogy Adrián majd ezt megosztja velünk hamarosan. Úgyhogy nem is szaporítom tovább a szót, akkor Adriánnak átadom a lehetőséget. Adrián, the stage is yours.
Okay, thank you. So good morning, everyone. Welcome to this VRNI webinar today. It's going to be a short one, just 30 minutes, but hopefully I will try to cover all the important aspects. So you will get very good VRNI nugget. So let me share my screen. Okay, can everyone see it?
Yes.
Okay. We are going to start with the network part, and this network map that you are going to see now, it's a new addition in VRNI 6.0. What we can do with the network map, first of all, we can see a very nice picture of our network. I will try to zoom out a little bit. As you can see, our lab network where we have installed this VRNI demo is very complex. We have a lot of things. We have virtual devices and then we have hardware devices. I will focus now on the hardware. So this is our hardware fabric in one of the data centers. So here we have an Arista switch. If we want to see more details about the switch, for example, the configuration of the ports, what VLANs we have and what ports are up, we can just click, and this is a drop down of configuration of basic configuration of the switch together with the software version, VRF, and management IP. We have other vendor switches as well. I just need to find them. Okay, so we are in the Arista fabric now. Here we have a load balancer. So this is an F5 load balancer, and this is a Palo Alto firewall. So you can see all of these in the network map. I will try to find, okay, this is a Dell switch. And probably around here, we also have some Cisco Nexus. Okay, this is a Cisco Nexus switch. So again, we can see details about the switch. For example, what ports are up, what ports are down, and what is the VLAN configuration. And then if the switch has alarms, like this Nexus switch has, we can see what these alarms are. We are going to cover this type of alarms a little bit later, but as you can see, we are alerting on the MTU mismatch, switch port down, trunk VLAN mismatch, which are very useful alarms in the day-to-day operations. Okay, what we can also see is you have this alerts button. If I click it, I will not have any alerts on the devices. If I click it back, then you see each device that has an alert has this exclamation mark. So you can quickly go to it and see what the alert is about. And we have a special screen for all the alerts. You can see here all the alerts on your network, and you can search for specific alerts using this search function. What you can also do in the network map is to compute the path between two devices, between two virtual machines, for example. So I will give you an example. I have one virtual machine that is called Nav web server. And this web server, I want to make sure that it can go to this Nav application server. So I will click on show path. Okay, and now I get the path. So it looks like we have 6 paths and 4 of them are blocked, but 2 of them are allowed. And I can even see the path on the network. So I can see that this is a tier 1 router inside the NSX. One of the hosts, probably the web server, is part of this tier 1 domain. And then the traffic exits the physical server and goes into this stealth switch. So this is the underlay. And then to reach the destination, it goes into another ESXi server and another tier 1 router. So the path details are here. You can look one by one, including physical network ports, so you know exactly how your traffic is flowing. Another interesting thing is that if the traffic for some reason is blocked by a firewall, and I will show you now a blocked traffic. So this web to database should not be allowed. So we are going to see it now. See, so all the paths are blocked between these two devices. And if I want to know who is blocking, I just go into the details and I see this IP ACL that blocks the traffic exactly at the VNIC level of this web server. So this means that we are talking about the NSXT distributed firewall. So if I want to see more details, I just click the ACL and I will get the rule ID, the sequence ID of the rule that is blocking my traffic. You see the action is dropped here. I can take this ID, go into NSXT manager and quickly identify the rule. And if I want to allow it, I just change the action inside the NSX and the traffic will be allowed. Okay. So this is about the network map. Now we are going to get into the security part. And I'm going to show you the security planning function. So security planning can analyze the flows, all the flows that VRNI takes. And it can do it for the last day or the last 30 days, for example, but we are going to analyze the last day flows because this will make our demo faster. And this is a great tool for the security teams to start the microsegmentation process. This is the type of the overall information that security planning is giving us. I will start with this information on the right. I have the traffic, total traffic distribution inside my data center. So I have east-west traffic. This is put as 100% because it's a very big traffic. So it's 316 terabytes. But we also have north-south traffic, which is just 1 tera. That's why it's put as a 0%. So it's 0 point something. Then you can see which traffic is VM to VM, which traffic is switched, and which traffic is routed. So the percentage of switched versus routed traffic. Also, you can see the top ports that are used inside your network. Now, if you want to micro-segment one server or a group of servers that are part of one VLAN, here is the list of all the VLANs inside the network, and we can just click on one of them. This VLAN is called VLAN 1058. And here we get information about the hosts inside this VLAN. So for example, we know that the servers inside this VLAN are publishing, are listening on 26 ports in total. And the list of the ports that the servers are listening to is here. And we have MySQL, we have this Dynatrace port, it's 443 actually. We have again 443. So this is the drill down of the ports. And you can also see the flows, the number of flows for each type of traffic. So as you can see, we don't have that much traffic for this VLAN. Now here, the external service is accessed is the number of services that my servers are accessing from outside. So, for example, it's this port 9000, maybe it's a database, or this 123, this is NTP port, so it looks like they are using an outside NTP server. And again, we have these flows numbers, so we have the number of flows for each application, and this is very useful because if you see that there is a lot of traffic for one specific port, you can drill down more and see exactly why this happens. And then we have the list of flows incoming and outgoing inside this VLAN. The list looks like this. So these are actually all the flows that are going and exiting this VLAN, and you can, for example, sort this by one of the metrics. I will take, for example, bytes, source bytes. Okay. Let me take another one, maybe. Okay, packets. Let's sort it by the number of packets. So it looks like we don't have that much traffic here. So the flows are very small, but you have a lot of ways to filter based on several criteria here. And then the important thing, or the interesting part, is these recommended firewall rules. What VRNI is doing is looking at all the flows, and then it's suggesting firewall rules that the security teams can implement in order to micro-segment this VLAN. What this means is that if the security team takes all these rules and put them in the firewall, and at the end they configure deny all, then this means that we are allowing all the necessary flows inside the VLAN, so the flows that are happening or did happen in the last day or the last month, and we are denying everything else. So we will be better protected in this way. Okay, we can show also here. So these are all the allowed flows, but we can also show drop flows. We don't have that many drop flows here. And we can also group our workloads by other criteria. So for example, we can group by Kubernetes namespace. So if you are into micro applications, these are the drop flows for the Kubernetes namespaces. We can look at the allowed flows. And here are all our Kubernetes namespaces, and we can see who is talking to who. We can click on this link between two namespaces, and we can see how the fitness namespace talks to the kube system. And it's just DNS. So one namespace talks to another, and it's just DNS requests. And we have obviously only one firewall recommendation to allow DNS between these two. Okay, so this is the security planning. And if we go back, I can show you the path. So the path, we can compute any path between any source and any destination inside our network. I showed you this on the network map. We can do it from here as well. I'm going to show you a very complicated path that we have. So this is our Hive video server. And this goes to our storage server for backup. Okay, so this is a very complex path. That's why it's very interesting to show it. Our Hive video server has the backup in the public cloud. So this is a flow between one of our data centers towards another data center that has the cloud interconnect. So everything started from this ESX016 in our data center, I think in Washington. Yeah, this is the Velo Cloud Edge in Washington. From this physical server, so we went to this NSX tier 1 because this is the gateway of our Hive video server. And the NSX tier 1 saw that the destination is external. So this meant that it forwarded the communication to the NSX edge. So NSX edge routed it to the physical network. In our case, physical network is this Velo Cloud SD-WAN device. And then this was routed to another location in Hillsborough, where we have another NSX edge. And this NSX edge has an interconnect with Amazon. And inside Amazon, of course, we also have NSX. We have this tier 1 router that this is the gateway for the backup server that's here. So this is the kind of information that VRNI can give you about the path between two endpoints in your network. Okay, so talking about SD-WAN, we can show in VRNI a lot of information about your SD-WAN network, your Velo Cloud SD-WAN network. Here, this is the overview, and we can get information about the total number of edges, number of hubs, number of gateways, and the total number of links, and also about the flows in general, edge to edge and internet flows. And here on this map, we can see what is the position of our edges. I'll only look into Europe. Zooming in, it looks like we have one in Netherlands, one in England, and that's it. And one, so two in England and one in Netherlands. Here I can get information about the versions, the software versions of my edges. Traffic distribution, I can see, again, these are very interesting traffic statistics. I can see how many flows I have from each branch location and what is the total traffic flow for each branch. What are the top applications that are used in my branches? And what are the pairs of branches that talk the most to each other? So here we have Rotterdam talking to Washington, for example, for a lot of traffic here. So these are very interesting information that you can get overall about your SD-WAN network. If we go into metrics, here we have very nice graphs about the total bytes transferred in the last day. What I can do, I can only select one branch, for example, Detroit. If I want to see how much traffic Detroit did, and maybe actually I can add another graph here and arrange them a little bit. And I can look at throughput. And I want to see only Detroit. So now I can see a total throughput for Detroit for the last day. You see here we had the spike, and then these are the total bytes transferred for Detroit in the same day. What I can do is, if I want to have a better look at this this area, the spike, now I zoomed in on the spike, and as you can see, I have one graph that is zoomed in, and the other one is not. If I click here, sync time, now I have both graphs synchronized. And I can do this for multiple graphs, not only for two. Good. So now if I want to see more information about edges, I can select one of them. So now I'm inside one location, the Detroit branch, and I can see the overall topology. I can see that behind this VeloCloud Edge, I have 6 IP addresses. I can see the SD-WAN tunnels and their quality of experience. For video and audio, but they are fine for transactional traffic. And again, here I can see from each, actually from this location towards the internet and towards other locations as well. So a lot of information that you can see in the screen for this specific branch. Okay, because we have around 7 minutes left, I will show you a very nice feature that we have. And this is actually our search bar here. So in the search bar, I can just type and the text is, so the input is contextual, so it's going to autocomplete. If I want, for example, to see the VMs group by operating system. Okay, so I want to see how many VMs of each operating system I have in my network. I just click, and here I have the list with all my VMs split it by operating system. So I can see that Ubuntu is the biggest, the most utilized OS in my data center, and then I also have some Windows 2016. If I want to see more information about, for example, these Windows ones, I can copy this and I can type VMs where operating system, okay, equals Windows 2016. Okay, not like this. Okay, not sure why this is not working. Let's see what the system suggests. Okay, so I can choose from here. Okay, wrong string. So here I can see all my Windows machines. I have 74 of them. And yeah, I can look at IP addresses. If I click on this plus, I can get more information about one VM. For example, on which cluster it is, if it's on the NSX or not, what port group it uses, and so on. Okay, another interesting search that we can do is related to network rate. So if I want to see what is the top talker in terms of network rate for my virtual machines, I can type this. Order by max network rate. Okay, so network rate of host order by max network rate. Okay, so this will show me my top talkers, my top talking hardware servers or VM. And in this case, I have this ESX12 that is my really top talker with peaks to 20 gigabits per second. So this is a good way, a nice search to see who is doing the traffic inside your network. Let me, sorry. Wrong click. I can show you another one. So if I want to see how many virtual machines I have on a VLAN, on a certain VLAN or on all VLANs, I can do VM group by layer 2 network, and it's going to show me what are the number of VMs for each VLAN. So this is a very good information to have. For example, this VLAN 1536 has 124 VMs. So this is quite a big one. Another one would be if I want to see which VMs are doing or listening for traffic or receiving traffic over one port. I can do VM where incoming port equals 443. Okay, so this will show me all the VMs that have services on port 443. And again, I can see more information about them. I can see the network IP address, the default gateway, which in this case is on NSX. It's a tier 1 router, the operating system, and the NSX manager IP address. And the last one, if I want to see all the flows where firewall action is denied, so I want to actually see all my denied flows inside the data center. This is the search for it, and I can see I have several external flows that are coming to one internal host, and they are denied. So this is a list with all the denied flows. Okay. So maybe I can also show you another one about VMs and CPU utilization. CPU usage rate is bigger than 30%. So I want to see all the VMs where CPU usage rate is bigger than 30%. Or let me see what I typed wrong here, bigger 30%. Okay. Maybe I can take this suggestion, top 20 hosts by CPU usage. So this is the top, these are the top 20 hosts by CPU usage. And you can see the top one has an average usage of 60%. So what I want to actually emphasize here is that VRNI is not just a network tool, it's also an infrastructure tool, because it can show you information like this. It can show you the CPU usage, the memory usage, and all additional details about the actual system, the actual server. Good. So I think we are on top of the time now. Thank you very much for the participation. I hope this was entertaining and it was good information for you. And we'll keep in touch via the local colleagues. Thank you again, and see you later.
Thanks a lot, Adi. It was a very impressive demo. Thank you so much. I will switch to Hungarian to say goodbye to the team.
First of all, just let's stop the recording and ask if anyone has